Unit 1, Level 3, Lesson Topic Number 2, Regrouping with a Distributed Property. Our essential question is, how does regrouping create equivalent expressions? Regrouping builds on the idea of multiplying two groups or a group of something together, but in a more complex way. And this leads to something called the distributive property, which we'll talk about later. But right now, let's talk about what our goal is, to create equivalent expressions. The definition of equivalent expressions are equivalent expressions look different but have the same value. So, for example, if I have 4 quarters, they are round, they are made of metal, they have some weight to them. In America, quarters have a picture of George Washington on the front and something different on the back. And that's very different from this piece of paper here, this dollar bill, right? It also has George Washington on it, but it has the number 1. It's made of paper. It's a different color. It's not made of the same material. So they look very different, but they have the same value, right? 4 quarters is the same value as $1. If I go to the store with 4 quarters, I can buy the same thing as if I went to the store with $1. Here's another example, one that's more mathematical in terms of just numbers. So let's look at these two integers, 5 times 3. We know that 5 times 3 is read as 5 groups of 3. Therefore, 5 times 3 and 15 are equivalent expressions because they have the same value. They look very different. One is broken down into factors. One is just a single number, but 5 times 15 has the same, or 5 times 3 has the same value as 15. Similarly, look at this expression, 2 plus 2 plus 2 plus 2 plus 2 plus 2. Well, this is repeated addition, and so if you see here, I have 1, 2, 3, 4, 5, 6 groups of 2, right, which can be written as 6 times 2, if we write repeated addition as multiplication. And we know that 6 times 2 is 12, and we know that 2 plus 2 plus 2 plus 2 plus 2 plus 2 is also 12. So that means that this long addition expression here and this shorter expression, rewritten 6 groups of 2, have the same value because the value of both of them is 12. Now let's look at a more complicated example. At first, this might look kind of overwhelming, but let's look at it in the idea of groups. Example 1, do 5 times the group A plus 3 and A plus 3 plus A plus 3 plus A plus 3 plus A plus 3 plus A plus 3 have the same value, and why? Well, let's look at the first expression. We just want to show that this expression and this long addition expression have the same value. So let's look at it in terms of groups. 5 times A plus 3 is a simple, it looks complicated because of what's in the parentheses, but this is simply a multiplication statement. So 5 times A plus 3 can be read as 5 groups of A plus 3, right? Remember, when we have 2 factors multiplied together, the first factor is the number of groups, and the second factor is what is in each group. So each group contains A plus 3, and there are 5 of them. All right, so that's the value of 5 times A plus 3, 5 groups of A plus 3. Let's look at the other expression. What do I have here? If you look at what's in the parentheses, I have the same thing added over and over again. And I don't know what A is, and I don't really care right now. All I care about is that I have a group of A plus 3 added together 1, 2, 3, 4, 5 times. Aha. So that means that this is 5 groups of A plus 3. So by looking at it, at each of those expressions in terms of groups, we have shown that even though they look very different, they are equivalent. Both of them represent 5 groups of A plus 3. So let's look at how we can go back and forth between these two kinds of equivalent expressions. For a moment, take a look at the screen, but don't write any of this down. This is not what's going to end up on your notes. The example says, write an expression or an equivalent expression for 9 times 7 minus x. Recall that using our understanding of multiplication as groups, we can say that 9 times x minus 7 can also be written as 9 groups of x minus 7, right? And what does that look like written out? It looks like this down here, which is why I don't want you to write this down, because we're not going to do this every time. Clearly, that's a lot of repeating the same numbers over and over and over again, right? Here's 9 groups of x minus 7. And then on the other side, the equivalent way of writing it would be to take x minus 7 and write it out 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. There must be another way to do this. And it turns out that there is. Rather than writing this out over and over again, let's look at what we have. If we have 9 groups of x minus 7, we can also say that we have 9 groups of x. If you count up the x's over here, you know there's going to be 9 of them. Likewise, we also know that there are 9 groups of 7. Because if we count the 7s here in this lavender purple, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are also 9 groups of 7. And we could say that those 9 groups of x minus 9 groups of 7 is an equivalent way to write this. So on your notes, this is what you should be writing. 9 groups of x minus 7 can also be written as 9 groups of x minus 9 groups of 7. So how do we translate that into an expression? Well, 9 groups means multiply. So instead of saying 9 times x minus 7, instead we say 9 times x for 9 groups of x minus, don't forget the minus sign here, and then 9 groups of 7. Now we know that 9 groups of 7 is 63, so we're going to simplify that, and your final rewritten expression is 9x minus 63. So 9 groups of x minus 7 can also be written as 9 groups of x minus 63. If that's a little confusing, that's okay. We're going to go through a couple of examples. Just keep in mind that the first number is the number of groups, and the second term is what is in each group. So here we go. Negative 10 groups of x plus 3. That means that I have, negative 10 is my number of groups, so the opposite really, but we'll just say negative 10. So I have negative 10 groups of x plus, since I'm adding here, and then I also have negative 10 groups of the second term in parentheses, x negative 3. And again, I'm just taking these two terms inside the parentheses and breaking them up so that then I have, I rewrite this, negative 10 groups of x here can be written as negative 10 times x, right, here. And then plus negative 10 groups of 3 can be written as negative 10 times 3. Now again, negative 10 times 3, we can simplify that to negative 30. And so you might write your answer like this, negative 10x plus a negative 30. Or more likely, you'll see it written like this. Remember that adding a negative moves you in the negative direction on the number line. So another way to write that is negative 10x minus 30. Let's look at one more. Write an equivalent expression for negative 7 times 2x plus 3. Negative 7 is the number of groups, and then we have that many of each number inside the parentheses. So we have negative 7 groups of 2x, and we have negative 7 groups of 3. When we translate that into an equivalent expression, we multiply. So remember, negative 7 groups of 2x means negative 7 times 2x, plus, and then negative 7 groups of 3 means negative 7 times 3. Now take a look at this one, because here you have a negative 7 times 2x, so there's some simplifying that can be done there. Negative 7 times 2 equals negative 14, and then just bring the x along. And then plus negative 7 times 3, a negative times a positive is a negative, so we're adding a negative 21. And we know that plus a negative can be rewritten as subtraction. So our final equivalent expression is negative 14x minus 21. At this time, you want to go back and answer the essential question. Remember, the good math summary is 4 to 5 sentences. It will define the vocabulary. It will give examples and explain examples that were talked about in the notes.